Let's continue this 1993 AP Calc BC multiple choice part of the exam. We left off on number 21. So we're asked to find the derivative of this guy at x is equal to 0. Okay, there's a trick to this problem. We could just blindly do the quotient rule, but it's going to get very tedious and messy. There must be an easier way to do this, and there is. Remember, we can use properties of logs when we have something complicated like this to make it easier. Okay, so I rewrote this guy as, up here, y is x squared plus 8 to the 1/3 power. Remember, 1/3 power is the same thing as cube rooting. The bottom is 2x plus 1 to the 1/4 power, okay? So this is this over here. All right, so let's log both sides. So we have log y is log of this guy, this whole guy. But remember, when we have a log of a quotient, we can do ln of the top minus ln of the bottom. So that's why I wrote here. So I did 2 steps in 1. So ln top minus ln bottom by properties of logs, okay? Here we can use another property where we can pull this power out in front of the log. So it becomes 1/3 log x squared plus 8 minus 1/4 log 2x plus 1. Now this is much easier to differentiate. So we differentiate both sides. So 1 over y dy dx is a third to constant. So what's the derivative of log? That's 1 over the argument x squared plus 8, and then chain rule times derivative of this guy, which is 2x, minus the fourth, that's the constant. Once again, we differentiate the log, that's 1 over the argument, times derivative of the inside, which is 2. Okay, we're asked to find dy dx at x is equal to 0. Okay? So let's move this y over. By the way, that's what I did. Okay, so when x is 0, what is y? So let's plug in y of 0 is, when we plug in 0, we get 8 to the 1/3. So cube root of 8 is 2. The bottom, we plug in 0, we get 1. So 1 to the 1/4 power is just 1. Okay, so 2 divided by 1 is 2. So we want the derivative at the point 0, comma 2. Okay, so we move this y over, so y times this whole guy right here. Y times this whole guy, okay? So I did 2 steps in 1 again. So y is just 2. So 2 times, then we start plugging in x is 0. So when we plug in x is 0 here, this whole thing would go away. What about when we plug in x is 0 in over here? So we get minus 1/4 times 2 divided by 1. So that's minus 2/4. And we simplify, that's just minus 4 over 4, which is negative 1. And that's our answer. Oops, there we go. So we solve this in a much simpler way than doing quotient rule on these two, which again will get very messy. All right, let's move on. F of x is x squared e to the x. Then the graph of f is decreasing for all x such that what? This is asking us when f is decreasing. That probably means we should find the derivative. So what's f prime? I did that over here. F prime, we need product. Well, first d second plus second d first. The first d second derivative of e to x, just e to the x. Second is over here, d first. What's the derivative of x squared? That's 2x, okay? I got confused by how I notated it, okay? We can factor out x and e to the x. So I guess I factor out e to x first, okay? So if you factor out e to x, that's x squared plus 2x on the inside. We can also factor out x, as I said. So we get x e to x on the outside, and then we get x plus 2 on the inside. We set this equal to 0 to find our critical points. So our critical points are x is 0 and x is negative 2. We do the first derivative test. We plug in some number much less than negative 2. So e is always positive, so we don't have to worry about that. When we plug in a huge negative number, this is negative. This would be also negative. Even if we add a tiny 2 to a huge negative number, that'll still be negative, right? So 2 negatives make a positive. You plug in some number in this interval, like negative 1. This would be negative, this would be positive, so the sign is negative. Plug in some huge positive number, this is positive, so the sign is positive. So 1 is f decreasing when the derivative is negative, so from minus 2 to 0. Turn 2 is B. Length of the curve determined by the equations x is t squared and y is t from t is 0 to t is 4 is, this is the arc length formula. So for parametric equations, it's very easy. So it's from 0 to 4 So the general equation is dx dt squared plus dy dt squared dt. Okay, so it's the integral from 0 to 4 of what's dx dt, that's 2t. We square that, plus what's dy dt, that's just 1. Okay, so inside would become 4t squared plus 1. So it looks like it is D. Okay. Let f and g be functions that are differentiable for all real numbers, with g of x not equal to 0 for x is not equal to 0. If limit as x goes to 0, f of x equals limit as g approaches 0 if g of x is equal to 0, and limit as x goes to 0, f prime of x over g prime of x exists, then limit as x goes to 0 of f over g is what? Okay, so what does this say? This looks very similar to L'Hopital's rule. Maybe that's what it's asking, okay? So let me see once more. F and g are differentiable. Okay, so they're asking for this. We know that when we plug in 0, we get 0 over 0. Why? Because, well, we can take the limit of the top and limit of the bottom and just divide it, right? So that's properties and limits. We know that the individual limits are 0, so it's 0 over 0. That's undefined. Sorry, indeterminate, not undefined. Indeterminate, because it's 0 over 0. Okay, so we can use L'Hopital's rule, so that's just limit as x approaches 0, f prime of x over g prime of x. Okay, that's just L'Hopital's rule. So 24 should be C. Let me check that's correct. Yes, literally definition of L'Hopital's rule. Okay, consider the curve in the xy plane represented by x is e to the t, y is t e to the negative t for t greater than or equal to 0. Slope of the tangent line to the curve at the point where x is 3 is, we want to find dy dx. That's slope of the tangent line. How do we do it for parametric equations? Dy dx is dy dt divided by dx dt. Okay? So dy dt, we have to do the product rule. First, d second plus second d first. So first, that's t. D second, derivative e to negative t is negative e to negative t. Plus second, that's e to negative t. Derivative of first is just 1. Okay? So that's dy dt. dx dt, that's just e to the t. Okay? We can simplify. We can divide through by... Actually, we could factor e to the minus t out. Okay? So what's left was minus t plus 1. E to minus t, we could move it to the bottom. E to t times e to t, that's e to 2t. We evaluate at t is ln 3. Because that's where... At the point where x is, so when x is 3, t is ln 3, okay? That's what I wrote over here. We didn't need this technically, but okay? When x is 3, t is ln 3. So we want to evaluate this derivative at t is ln 3. This we need to calculate. You should get minus 0.011. That is D. Okay. If y is arctan e to 2x, dy dx is what? We just need to chain rule. What's the derivative of arctan? That is 1 over 1 plus the argument, so e to 2x squared, times the derivative of e to 2x, that's just e to 2x, times the derivative of 2x, which is just 2. Okay? So which guy is it? It should be a 2e to the 2x on top. It looks like it is B, and it is, okay? So remember, if it helps you out, you can rewrite y as arctan of the exponent of 2x. This helps you to visualize outside in for the chain rule, okay? Derivative of arctan first, and then derivative of the exponent, derivative of 2x, okay? Okay, interval of convergence for this guy is, when it talks about interval of convergence, that just means ratio test. Okay, we can do it the long way, or you can realize that this is just a geometric series where we can rewrite this as x minus 1 over 3 to the n. This is just a geometric series where x minus 1 over 3, the absolute value has to be less than 1. okay? Or the absolute value of x minus 1 has to be less than 3, which means that x minus 1 has to be less than 3 but greater than negative 3, which means x is less than 4 and greater than negative 2. So this is the short way to do it. If you didn't recognize this, we can do it the long way of the ratio test, which is what I did over here. Okay, limit as n goes to infinity of a sub n plus 1, so e x minus 1 to n plus 1 over 3 to n plus 1. So we just n plus 1 to both those, and then we multiply it by the reciprocal of this guy, because it's a sub n plus 1 over a sub n. So that's the reciprocal. We can cancel things out because x minus 1 to n plus 1 divide by x minus 1 to the n. That's just x minus 1 to the first power. And similarly, 3 to the n divided by 3 to n plus 1, that's just a third. Okay, so we are left with this. This limit does not depend on n, so the limit is this guy. Okay, we do the same thing. We set this equal to, we want it to be less than 1 for the ratio test to converge. So x minus 1 absolute value is less than 3, and we get the same interval over here. But we have to check the endpoints, because remember, the ratio test is undefined when it's equal to 1, or not undefined, it's indeterminate. We don't know the result, okay? Inconclusive, that's the word I'm looking for. Okay, so we have to check the endpoints, negative 2 and 4. Okay, so when x is negative 2, we just plug in negative 2 into here. We get minus 3 to the n over 3 to the n. Okay, we can simplify this as minus 1 to the n, 3 to the n over 3 to the n, and the 3 to the n's can cancel, so it's just minus 1 to the n. We know this series diverges because, well, first of all, we can do a test for divergence. Limit as n goes to infinity of negative 1 to the n, that doesn't converge. It always alternates, right, between plus 1 and negative 1. Never converges to a value. So this one diverges. And now how about this one? When x is 4, we plug in 4 into here. That's just 3 to the n divided by 3 to the n. Whoops. Okay, so those would cancel to summation of 1. Obviously, when you sum up an infinite number of 1s, it's going to become infinity also, okay? So we don't include the two endpoints because we just found that they diverge at the endpoints. So it's from negative 2 to 4, both not inclusive. So 27 should be C. Okay? Particle moves in the xy plane so that at time t greater than 0, its position vector is this guy. Then at time t is 2, its velocity vector is what? So we just want to differentiate the vector. So we differentiate the components individually. Okay? So I called this guy vector r. Okay, so that's the same thing as this. So we differentiate the x component. That's just 1 over the argument of the log times derivative of the argument. So 1 over t squared plus 2t times 2t plus 2. Okay? Derivative of this guy is just 4t. Okay? We want the velocity vector at time is 2, so v vector 2, which is the same thing as r prime 2, I don't know why I wrote that, is equal to, we plug in 2. So it will be, what, 6. This guy would be 6. 6 times 1 is 6. The bottom would be 4 plus 4, which is 8. And we plug in 2 here, that's just 8. So 3 over 4, comma 8 should be your answer. We have this integral of x secant squared x dx. We have a product of two things, so the good candidate would be integration by parts. With that u be x, du is dx, dv is secant squared, v is tangent. Okay? Why did I choose it like this? Well, conveniently, I know what or you should know what the antiderivative of secant squared is. It's just tangent. So that's why I chose that. Okay? So if we do integration by parts, that's uv minus integral v du. So uv is x tangent x. Minus integral v du, that's minus integral of tangent x dx, okay? So this, if you memorized it, great. If you don't, you can just do a substitution again, because you can change this back to sine over cosine, okay? But since I remember it, it's x ln x minus ln of secant x plus c. Okay, I don't see that as one of the answers though, but I know it's this one. Why is that? Well, I can bring this back inside. So instead of negative 1, I can make it plus, but bring the power inside. So secant x to the negative 1. So we want to invert the secant, so that becomes cosine. So x ln x tangent x plus ln cosine x plus c. 29 is E. What is the volume solid generated by rotating about the x-axis, the region enclosed by the curve y is secant x, and the lines x is 0, y is 0, x is pi over 3. Okay? So if we sketch this region, how does this region look? How does secant x look in the first quadrant? Because we're bounded by x is 0 and y is 0. Okay? So remember how the secant looks? Looks something like this. There's an asymptote at pi over 2, because we know secant is undefined when it's pi over 2, okay? So we just want to chop it off from 0 to pi over 3. So it'll be somewhere here. Let's say pi over 3 is over here. So this would be your region over here, okay? We want to rotate this about the x-axis, so over here. So I draw a representative radius, r. So the volume would be pi integral r squared dx, which is pi integral from y limits of integration. Our region is bounded by x is 0 and x is pi over 3. What is r? What's this length? That's just secant x, right? So it'll be secant squared dx. Okay? This is easy to integrate. That's just pi times tangent x, evaluate from 0 to pi over 3. What's tangent pi over 3? I believe that's root 3. What's tangent 0? That's just 0. So it should be pi over 3, pi times root 3. Okay. Moving on. If I can flip the page. Okay. We have the sequence S sub n is this whole thing. To what number does the sequence converge? Okay. So we want to take the limit as n goes to infinity of this whole thing. Okay, so that's what I wrote over here. And this is quite easy because, well, first of all, we can simplify this 5 to the n divided by 5 to the n plus 1. That just becomes a fifth, which I can pull out of the limit, actually, which I did over there. Yeah, so this simplifies a fifth, and then I pull it out, okay? So we're still left with this. How do we find this limit? So the easy way, as I said it many, many times, this is just a horizontal asymptote. Okay, so the degree of the top and the degree of the bottom, what are they? Well, when you expand this whole thing out, the biggest term is n to the 100th power. That's the degree. Same thing for this. They're the same degree. So what's the leading coefficient? They're both 1 when you expand it all out, because this is just the biggest term, right? So it would just be 1/5, because this limit would just be 1, okay? So it'll be 1/5 times 1, which is 1/5. If integral from a to b, f of x dx is 5, integral from a to b, g of x dx is negative 1, which of the following must be true? F is greater than g for x is between a and b. That is not necessarily true. You might be tricked because, oh, well, integral is area. Since this area is bigger than this, it must mean that f is bigger than g. Okay? That's not always true within the whole interval, because we can have f starts negative. Like, okay, assume g is, well, g is negative, okay? So let's assume g is a constant value. It won't be constant, so that's not a good example. Let's just, g is negative, right? F can start more negative, but it can become positive eventually, as long as it does between this interval, and it's more positive such that the area would eventually equal to 5. Okay, hopefully that made sense. So let me even sketch it out. Let's say g is somewhere down here, okay? So obviously it's just this area right here. But f could start down here and then increase up to there or something like that. This is not a good sketch, but imagine it's more squeezed in. So it's like this or something like that, okay? So let me redraw it, okay? So if this is g, this is f, okay? Because this one, there's much more area up here that it could eventually add up to 5. It will cancel out this negative area down here, okay? Hopefully this makes sense. So f could be smaller than g within this interval, but eventually it has to be bigger because the area is bigger. But it could be negative at some point, okay? So we cross that out. This one is integral from of a to b, f plus g. Okay, so we can use properties of integrals. That's just, let me do it over here, integral from a to b, f of x dx, plus integral from a to b, g of x dx. Okay, this is 5, this is -1. We add those two together, that's 4. So this is good. Okay, and this is clear that you can't just multiply two. There's no property of integral that says you can just multiply those two. Okay, so 32 is 2 only, which is b. Which the following is equal to integral from 0 to pi sine x dx. Okay, so the slow way would be to evaluate all of them. That's not a good way. Okay, we can visualize what this is in terms of area. We know how sine looks, we know how cosine looks. Okay, so let's draw what sine x looks like. Looks something like this. Okay, let's say this is sine x, and we can even go in this direction. Okay, if this is 0, this is pi, this is 2 pi, this is minus pi, this is minus pi over 2, this is pi over 2. Okay, so this one is the integral from 0 to pi, so we are interested in this area right here. Okay, let's draw what cosine looks like. Starts at 1 at x is 0, so it goes like this. Something like that, okay? This is 0, this is what, pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. Okay, this one would be minus pi over 2, this is minus pi, this would be minus 3 pi over 2, this is minus 2 pi, something like that, okay? I didn't need to draw all that, but we can easily visualize that the integral from negative pi over 2 to pi over 2 would get the same thing. Okay, so it should be A, as simple as that, okay? Okay, in the figure above, PQ represents a 40-foot ladder with NP against a vertical wall and NQ on ground level ground. If the ladder is slipping down the wall, what is the distance RQ at the instant when Q is moving along the ground 3/4 as fast as P is moving down the wall? Okay, that's a math symbol. So what is it saying? It says ladder is slipping down the wall. Okay, so let's call this guy X and let's call this Y for simplicity. Okay, we know that we might have to use the Pythagorean theorem, which says x squared plus y squared is 4t. Okay, we might need that, so let's write that down. Okay, what else does the problem tell us? Ladder is slipping down the wall. What is the distance RQ at the instant when, okay, so distance RQ, so they're asking for x. Okay, so let's write it like that. At the instant when Q is moving along the ground 3/4 as fast as P is moving down the wall, okay? So Q moving along the ground, so that's dx dt, is moving 3/4 as fast as P is moving down the wall. So that's dy dt. We got to be careful here, though. Dy dt would be negative, actually, so we want to put a negative sign, okay, to make it positive again. Once again, dy dt, because it's moving downward, it's negative. So we want dx dt to be positive, so we put another negative sign to get rid of that negative sign from the dy dt itself. Okay, so now that I wrote that, does this help us to solve the problem? Well, let's differentiate this guy. So when we differentiate, that would be 2x dx dt plus 2y dy dt is equal to 0. Hopefully it's visible on camera. Okay, so why did I want to do that? Well, let's start plugging in things, okay? We don't know what x is, we want to find that. We have some ratio of dx dt that would eliminate one of the two. We don't know what y is. Actually, we do know what y is because we can get y from here. Okay, so then we know what dy dt is. So let's just start plugging things in. Okay, so actually, yeah, let's just plug in what we know. Let's plug in dx dt as this guy. Okay, so it'll be 2x minus 3/4 dy dt plus 2y dy dt is equal to 0. So we can cancel a 2 from these two, because if we factor it and divide it on both sides, then 0 divided by 2 is 0. So we can just get rid of those. Okay. Let's maybe solve for what did I do before? So I took the derivative. Now we have these variables still. And we could also factor out the dy dt. Okay, so we can factor out 2, and we can factor out dy dt. So we can factor out a 2 dy dt and divide both sides by 2 dy dt. So then this would also go away. Okay, so we're left with x times negative 3/4 plus y is equal to 0, or y is 3/4 x. Now we can plug this guy in back to here to find what x is. So x squared plus, this is visible on camera, it is, plus 3/4 x quantity squared is equal to 4t squared. I left out a squared over here. Okay, so now we can just solve for x, because this would be x squared plus 9/16 x squared is 4t squared, okay, which we can say this is what? 25/16 x squared is 4t squared, okay, and then we just solve for x. Plug it into your calculator. X is 32. That's choice E over here, okay? So this one's a little more challenging in that we weren't given all the variables to solve the related rates, but we still were able to find it because we found a relationship between y and x. So we could eliminate the variable. Okay? If capital F and lowercase f are differentiable such that capital F is integral from 0 to x, f of t to t, and if f of a is -2 and f of b is -2, where a is less than b, which the following must be true. This sounds like Rolle's theorem because they give us two places where the y value is the same. Okay? Remember what Rolle's theorem says? It says, okay, let's do it in terms of these two. Okay? It says if f of a is equal to f of b, okay, assuming they're continuous and differentiable, which we know they are, then there exists some point C in between A and B such that capital F prime of C is equal to 0. Okay? That's what it says. What is capital F prime? Capital F prime is just, we differentiate over here. That's just fundamental linear calculus. That's just f of x. Okay? So there is some C such that f of x is 0. Okay? So that looks like 35 is A. Okay? You got to be careful about your capital F and F. Okay? And actually the key says apply mean value theorem, which you could do, but you could also just do Rolle's theorem, which is what I did. Consider all right circular cylinders for which the sum of the height and circumference is 30 cm. What is the radius of the one with maximum volume? Okay, so this will be the last problem I'm going to do for this video, this part of the video. Okay, so this is an optimization problem. What did it tell us? We want to optimize the volume. So what's the volume of a cylinder? That's pi r squared h. We have two variables. We want to get rid of one of them, so we need a secondary equation. And they tell us that the sum of the height and circumference is 30. So height of the cylinder plus circumference, that's 2 pi r, is 30. So we can solve for h, which is 30 minus 2 pi r, which I plugged into here. And that's simplified over here. Okay, that's 30 pi r squared minus 2 pi squared r cubed. So we differentiate v. What do we get? We get 60 pi r minus 6 pi squared r squared. We set this equal to 0 to optimize it, okay? We can factor out a 6 and a pi and a r from both the terms. So 6 pi r times 10 minus pi r is equal to 0, okay? Now we can find our critical points. R is 0 and r is 10 over pi. R is 0 won't help us this new cylinder then, okay? So let's take this point. Let's confirm that it's a max at that point, okay? So we do the first derivative test. 10 over pi, we plug in some number less than 10 over pi. For example, 1, okay? Because remember, pi is 3.14, so it's rounded to 3. 10 divided by 3, it's like around 3, okay? So we plug in like 1. This would be positive. This would be positive. 2 positives make a positive. Plug in some huge positive number. This would be positive. This would be negative, so it's negative there. So we confirm that it's the max at 10 over pi when r is 10 over pi. We want the, okay, it asks for the radius, so it's just e then. Let me confirm. Yes. Okay, that's it for this part of the video. Hope you found it helpful. Please like the video if you did, and please subscribe also to look out for